All right, so one way to think about paths is to think about the Russian nesting dolls. So this concept that each subsequent file or folder would be inside of another folder. So for example, on your desktop, that's sort of, it's got this hierarchical structure. On your desktop, you might have folders inside of it. You might have a folder that's got all of your classes. And inside that one, you might have one that's called Intro to R, that's got all of our work for the class. And perhaps inside that folder, you also have a folder called data. And besides one single folder inside of a folder, you can have more folders, right? And you can also have files. So you might have your code in the Intro to R file, and you might have your data in the data folder. So if you were to make an absolute path, you would have to say, I'm in the desktop, I'm then inside classes, I'm then inside intro to R, I'm then inside data to get to the data file.csv. So here you can see down here where the path would be for that. And so looking at this another way, you've got from your desktop another folder inside called classes, another folder inside called intro to R. This has your code. Another folder called data, there's your data file. And again, this is the path to get all the way to the data file. And so our code, we can't tell where anything is except for absolutely across our entire computer. So we have to show the computer where it is in a full absolute path. But our RStudio projects can be super helpful for this because they put they allow for your for files to just be found relative to this file. And so if you put your code files where your project file is, that's the simplest. In fact, if you also put your data files not in a subdirectory, but just right in there with your project file, then you don't have to write any sort of path. You can just say the name of the file. But if you happen to put your files inside a subdirectory, so for example, you have your R project in your intro to R directory, but then you have another directory within that that's called data. If you happen to have it set up like this, then you have to specify that your data is within data now from using the R project. But you can see that this is a much simpler path. So we have our R project file and our code in this main directory for the class. And then we're just looking within data, where's our data file? Okay. So then looking at it in this format, we see that our R project is here. And now because our R project is here, the only paths we have to look for are from here. And so we only have to do 2 steps. We just have to go from data to the data file. I hope that clears up some confusion. I have a more complicated example on here for those of us who were in my lab session. I'm not going to show that now, but we'll add this link later today to the website. See some chats.
And we also have some other materials we'll try to provide, just because sometimes it takes a couple ways of thinking about this before it kind of, I get it.
Yeah, it is definitely a tricky concept. Okay, so go back to finding my slides here. Okay, so I'm going to the website. Going down to the schedule. We're already on day 3, if you can believe it. And today we're going to talk about subsetting data, which is one of my favorites. So we're really going to start manipulating data, which is exciting, in my opinion, at least. So just to recap some other things that we've already talked about, R can function as a calculator, which we saw was really nice and nifty. So I basically never use a calculator ever. I always use R. You can use the combine function to combine vectors and to combine different values together. To assign objects, we need to use this backward facing arrow. If you don't use this arrow assignment to reassign objects, if you're modifying them, then if you look at them again, they're going to be the same as they were previously. So you have to reassign them to be whatever modification you're trying to make for that to actually stick. Otherwise, you're just going to see a printout of the results onto your RStudio. And so we'll show that, and that'll become a little more clear, but that's an important thing to keep in mind. We talked about how length, class, and str can help give you information about your object, and how head and tail can show you the top and bottom. We talked about how spec can help you check data specifically read in with readr. If you're not looking at an object read in with readr, then spec might give you null. So that's important to keep in mind. And then we talked about how readr has some really great functions like read CSV, which helps you read data into R, and also how to export data from your working environment called write RDS to make this special type of file that allows you to just double click on it from the file pane, and then that will load that data into the RStudio environment, which is really helpful because you'll see as we go through today, sometimes you're going to do a lot of steps to clean up your data and you don't want to necessarily run through that whole process again. And so it's nice to be able to save an R version of your data. There's a link here to the cheat sheet from what we discussed yesterday. Okay, so today we're going to cover a lot of material. We're going to talk about additional ways that you can look at your data. We're going to talk about how to create a data frame versus a tibble, and sort of some of the differences there. We're going to talk about how you create new variables or columns, and how you make row names from a column. We're going to talk about renaming columns. We're going to talk about subsetting rows, so filtering out rows that you don't want and keeping only the ones that you do, how to only keep certain columns, how to remove and add new columns, how to order columns, and how to order rows. So we have a lot to get to. I see a couple of chats. Just going to check that. All right, thanks for helping us there, Ava. And indeed, this is a great option for a time to use the RDS file if you have a really big data file that you have to import. You don't want to necessarily do that again. So that's a great question. Okay, so just to recall, we're going to focus on the tidyverse. And the reason we're doing that is it's just a really intuitive way, particularly for wrangling data, and that's what we're doing today. And we're going to focus specifically on the dplyr package. There's a bunch of resources here if you want to learn more. And so it's kind of a weird name, dplyr, and a lot of people don't know how to say it necessarily. And so why it's called this is it's D for data frames and plier for, the actual tool plier. And so this is from Hadley Wickham, who developed it, and he's saying you can pronounce it however you want. So you got permission here from the guy that developed it. A lot of people call it dplyr though. But so the idea is to help you get your data into the right form so that you can really work with it, which is super important. And so, we had you install the JHUR package, which installed the tidyverse, but if you want to use it, each time you got to load the tidyverse library. And so dplyr is part of the tidyverse. Okay. All right, so first we got to start with some data to get started here. So when we install R, it comes with some data already automatically. And so we're going to use some data, the toy data basically, that's within R. And so if you were to type in empty cars into your RStudio, you're going to actually see something happen, because that exists already in R. And so we're going to make a copy of that and call it data frame because we don't want to modify the existing empty cars. If you were to, that's okay. The next time you load R, it's going to be refreshed. but it's helpful now to have a different copy. And I'm going to see if I can also share my RStudio. Okay, do you see both now?
Looks good.
All right. So down here in my console, I'm typing empty cars. I actually can't see it myself because my Zoom tools are covering it. That's my terminal. This is the console. That's why it said not found. Okay, so when I type it in, I see data. So I see a bunch of data about a bunch of cars and data related to cars. I'm not a car person, so I don't honestly know what a lot of it is, but that is not important for what we're doing. Okay. Can we see the slides okay now if I switch back? Okay. All right, so we're just using the head function here to take a look. And so here's a few new functions that are really helpful for understanding the dimensions or size of your data. So dim stands for dimension. And so you just put that around your data that you're interested in. And here we see that there are 32 rows and 11 columns. But if we want to just look at the number of rows or the number of columns, we can use these functions. And glimpse is an extremely helpful function for taking a look at your data. It turns your data sideways. So this is the same empty cars data, it's just turned sideways now. So these are the columns here on the left, and these are the values on the right. So if you want to get a sense of kind of the breadth of the values and you want to see all of the columns, glimpse is a really good option. Studio. Okay, so here you can see the data here. And if I expand my screen and do it one more time, I can see more values. And if I have a lot of columns, I'm going to see all of them here. So that's a really helpful aspect of this. Okay. All right, another really helpful function is slice sample. And so you're taking a random, so sample basically often means we're sampling out a random part of something in R. And so we're slicing out some of the samples from our data. And so in this function, we have a couple of arguments that we can use. We have an n argument and a proportion argument. And so if we use the n argument, we can specify that we want, for example, 3 random rows from the data frame. Or we can say that we want to see 20%, a proportion here of 0.2. Just making sure we're good in the chat.
I think there was maybe a good question. Can you remind us what DF is?
So we made data frame DF from empty cars here. Just made a copy of empty cars. So remember, if I type in empty cars, I see the data, but I don't want to necessarily use that data and change it. So I'm just making a copy of it. And so now when I type in DF and I'm calling it data frame, it's the same data. And so importantly, if you use slice sample, each time you use this, you're going to get a random different set of 3. And we'll be doing some random sampling work in our lab, which will make that more clear. There's also a really great function or package called Skimmer, and you would have to install Skimmer using the install packages function to get Skimmer if you wanted to use it. But I just wanted to point it out to you because it gives you this really awesome table with visualizations about it. And so you would use the skim function. And again, DF here is our data that we're working with, which is the copy of empty cars. And so here we see the car related variables here on the left. It shows us how many missing values there are, if they're fully complete, the mean, standard deviation, information about quantiles, and a histogram. So like, for example, this variable here, what is this, VS, I think, it's showing that it has sort of a binary distribution. So we have most of the data in 2 extremes. So that can be really helpful to see. Okay. All right, so now we're going to talk about the difference between data frames, which are base R, and tibbles, which are basically the same type of thing, but the tidyverse version. And it's basically a fancier version. Technically under the hood, there's less going on, but you will see more. So to create a data frame, we can use the data.frame function. And so in this case, I'm making a data frame out of DF, which happens to already be in data frame form, but say this wasn't, I could use data.frame to coerce it into the data frame format. So if I had a tibble and I wanted it to be in data frame, I could do that, for example, to get it back into a data frame type of structure. And so you'll notice here that our column names are directly above the values. So remember how I said that it's important to reassign? If I had a tibble version of data frame and I really wanted to keep the data frame version, I would have to reassign it to data frame itself or make a new object so that I could continue to work with that. And if I don't want it to overwrite what DF is, then I need to, I need to make a new object. So in this case, we're overwriting it. We're changing DF to have this data frame structure. So we can also make data frames by using the read.csv. So there's 2 functions. There's read_csv from base R, from read R, and then read.csv from base R. And this will make automatically a data frame from a CSV file. And this is just a toy path. This will not work on your data probably. All right, so tibbles though are instead a fancier version, and we'll see why that can be really helpful. So to create a tibble, we're going to use the dplyr function tibble. And so I'm just using this notation here with the 2 colons and the package name to indicate where this is coming from. You don't really need to worry about this. You can just use tibble data frame. And you'll notice here, I've made a new object called TBL or tibble, short for tibble. So I didn't overwrite my data frame. I made a new object. And when I take a look at that, I didn't just type tibble in. I don't even have to put head. And it shows me an abbreviated form of the data, which is nifty. So that's already one benefit. But we can also see that underneath the columns, there's information about what class each of the different columns are. And you don't have to worry about that too much for now because we're going to talk about classes tomorrow. but just note that this is, useful because you get that information. The other nice thing that we are going to work with today is that we get the dimensions. So we see that there are 32 rows and 11 columns. And we can automatically make these if we use the read_CSV function, like we did yesterday from the readr package. So let's put that all together because it might be a lot. So if we use read.csv, which is base R, comes on automatically with R, then we will create a data frame. If we have an object that we want to make a data frame that we're not reading in, we're not importing it, then we can use data.frame. If we want to make the fancier tidyverse version called a tibble, we can use the read_CSV function from readr, or we can use the tibble function. So we generally recommend using tibbles because there are these advantages to them, but data frames are also very powerful. So whatever you end up working with should be fine. Okay, so another specific variation that's important to keep in mind is tibbles don't have row names. So in tidy data format, row names are removed. So if your data happens to have row names and you create a tibble from it, you are going to lose them. So here we can see an example of that. So here I'm looking at my data frame and I'm using head to do that. So I'm just looking at the first two rows and you can see that I have row names here. So they're to the left of my columns and they identify what car I'm looking at. But if I make a tibble version of the data frame, so here I'm nesting two functions. First, I'm making a tibble version of it, and then I'm taking a look at the top two rows. You can see that there's nothing to the left. So I've lost those row names, which could be a problem, right? Sometimes we need those. Yeah, in a sense, row names are another variable, but technically here they're formatted differently, right? Because they're to the left and they're not a variable because they're not a column here. And so that's why tidyverse has them get removed because it wants them to be in a column because it's easier to work with columns in the same way as other columns. And so there's a nifty function to help us out with that because indeed we don't want to lose that data. So we can use the row names to column function to keep the row names. And so we're going to make a column from the row names. So we want to do this before we turn it into a tibble because otherwise we're going to lose the row names. So here we're going to say row names to column from our data frame, which is the empty cars data. And we're going to call the new column car. And then I'm just looking at the first two rows of this. So now I have a new car variable. It's the first variable, it's the first column, and it has the information from the cars. So if I look back here, see how there's nothing above this? Now that I've made it a column, it says car, and there's nothing to the left of our numbers here, indicating the rows. And so if I make a tibble version of this now, I can see that now I have all of my data, which is great. So that's how we would fix that issue. And we don't always have row names. A lot of data doesn't have row names automatically, so you don't even need to do that. Row names to column is a function, and it is part of dplyr. So when you load dplyr with library dplyr, you will also get this row names to function to column function. Okay. The dplyr package, dplyr. All right, so now we're going to talk. Is there a question?
Yeah. We are importing, as well as from other form of data files into R, where the row names are literally have a column name. For example, for as to the example you provided us, if it is an Excel file, it will be car type or car name, whatever. That will be, so would that not be also imported into R when we import every other thing? And the need for renaming or the rows into column name may not be needed. So I need some clarification on that, because I'm trying to relate with what I know and build up from what I know.
Yes.
Thank
okay.
you.
So indeed, if you were to import some data that you had been working with in Excel, you would have your row names as a column. And so that would just get imported just fine, and you wouldn't have to worry about renaming or moving your row names into a column. But sometimes you might work with data in R that has row names, or you might work with a collaborator that uses an older form of R where people typically had row names. That's also common in certain types of genomic data if you work with that. So just something to keep in mind. So we're going to start talking about renaming columns. Sometimes your columns are named in a way that you don't want and you want to change it. So for example, here we have a lowercase version of miles per gallon in our data, and let's say we want it to be capitalized because we want people to know that that's an acronym. And so this is a slightly tricky function. We're going to use the dplyr rename function, and we're going to basically first have our data that we're creating or assigning. So this could either be the data that we're changing, that we're reassigning, or new data that we're creating. We're going to use the rename function, and then we'll have the data that we're starting from. And then we'll have a comma followed by the new name equals old name. So I don't know about you, but I always found this a little bit confusing to have the new name listed first, but this is how it works. So we want MPG caps in all caps to be first equals lowercase MPG. And so we would use rename. We're going to work with our data frame. This is the new name for the column. This is the old name for the column. And we're reassigning data frame. So we're changing data frame. And if we look at data frame using the head function, we can see now that MPG has changed. If you just used an arrow from MPG to M, if you used an arrow within the function, that would cause an error because the function is expecting an equal sign. Okay. So sometimes we want to change all of our names, and we can do that with the rename function and rename with function. It used to be all, which I think was a nicer name, but it's now with, which can be helpful if you're doing some other things that are more complicated. But anyway, so if we want to rename all of our columns, we have to use the rename with function. And there are some functions that are helpful in case we want to change the format So there's a toUpper function, which changes all of the column names to an uppercase, and the toLower would change to lowercase. Yeah, sorry, I misremembered that row names to column name is from the Tibble package instead of dplyr, which is very similar. So if you load tidyverse, this will always, they'll both come up, which is why it's a good idea to do library tidyverse. There's like, I don't know how many packages I work with, but sometimes it's hard to remember all the details. I apologize. Okay, so, but this one is definitely from dplyr because you can see here that I ran the code using dplyr. And these slides, in case you weren't aware, are created with R. So that's, you can be sure that this was made that way. All right, so in this case, I'm going to use my data frame and I want to rename everything to be uppercase. And I'm going to make a new data frame called data frame upper. Looking at the first 3 rows here, I can see that everything is now uppercase. And because now everything's uppercase, I can take it all to be lower. If just one of them was uppercase, the same thing would work. It would just change that single column. But it just tells it to make everything lowercase. Okay, so in summary, data frames are a simple version of a data table, which is basically like kind of an Excel type of version of our data. It's got rows and columns, and sometimes it has row names. Tibbles are a fancier version, and they come from the tidyverse. And so they show you information about the dimensions and some other things that we'll talk about later. Data frames are made with data.frames or using read.csv from base R. Tibbles are made with Tibble or read underscore CSV from the readr package. And the rename function and the rename underscore with function help you to rename columns from the dplyr package. And also from the Tibble package, we have the row names to column names if we need that. And again, sorry for that. Okay. All right, so now we're gonna move on to our first lab for the day. Okay, hopefully we're coming back from break. So Ava has a nice option, which I meant to go over this morning too and forgot. So I'll share my screen briefly. If you're struggling still with the paths, just a second. There we go. Actually, I guess I need to show my full screen. So just try that again. Okay, so on my desktop here, I can go to File in RStudio. Can you all see this? Hopefully. Okay, good. And then import data set. And then I want to use readr because I want to use read underscore CSV instead of read.csv. So depending on if you want a data frame or a Tibble. And then it's going to pop up. I can browse. I can either use a URL here or I can look for the file. And so here you can see all of my files, and I have a ton. So but maybe they're in my data, which they are. And then I would find the CSV file that I want. All right, so now we're gonna get back into subsetting. Yes, that's right. yeah, your data directory, if you have your data in a data directory, it should be in the directory that has your project file. All right. So back to the lecture. So now we're going to talk about subsetting columns. So say you want to look at a specific column. So this is the base array, which involves this $sign. And we're showing this to you because you're going to see it maybe in your collaborator's code or online. But it isn't very compatible with the tidyverse packages. So if you just want to look at it quickly or something, you know, it's good to know about and you can use, but try not to mix and match with tidyverse because it won't always work. So the tidyverse equivalent is the pull function. And so you can see how this is a little more intuitive because in a sense, in terms of being able to read it out like a sentence. So we're going to pull out from the data frame that we're interested in working with. In this case, it's that DF data, which was the copy of empty cars. And we want to pull out the carb variable. And so we're going to pull out the values that are from carb. And so hopefully you can see my screen here. Oh, this will give you an error if you copy paste because you'll have curly. So for example, if someone puts something in the chat and you copy paste it, you'll get an error message sometimes with quotes because they're curly quotes, because in R quotes look like this, they're like flat. Scrunch this up just a bit. Okay, so if you recall, we made DF from empty cars. And so when we look at the top of DF, we'll see the carb variable here and we can see the values. And so now I'm just doing pull DF. And so now we see all the values. I can't see all of them here in head because I'm only looking at the top, but here I can see all of them. So that's kind of nifty and helpful. Yeah, I zoomed up some weird formatting things and also some other places from copy pasting. So important to keep that in mind. Okay, can we still see the slides okay?
I don't see the slides.
Okay. Okay, how about now?
Yep.
All right. So now there's this other function called select, which instead of giving the values, it's going to show a nice table version or table-like version. So in this case, it's going to show us like a column name and show it in like a long sort of format. So you know, if you're following along, you could even like copy paste here. Oops. And so here we see the MPG object here. And because we're working with a data frame, we have our row names here on the side. Okay, so you can actually use them together. You can use pull and select at the same time. So again, if you want just the values, you want to use pull, but perhaps you wanted to do something fancier. In this case, you don't need to, but we'll see later that you might have a fancier subsetting that you're doing where you're selecting several columns and you want to pull out certain values, you could combine them by nesting them. Yeah, if you changed MPG and you never changed it back to lowercase, then you would have to do that. That's a good point.
You'll get a weird error that it can't find the column, yeah?
Okay, so pull is gonna give you the values, so they're just listed out. Whereas select is going to make a table version of it. I'm in the compound version, which is unnecessary in this particular instance. I'm saying I want to pull out MPG, or I want to select the MPG column, and then I want to pull out the values. Okay, so then we can do some cool things also with it, where we can match patterns. So you notice that there's a couple of columns here that start with the letter C. So we can use some really nice nifty functions like starts with and say that we want to look at letter C, and it will select those columns. And so there's lots of helper functions that help us to select based on a pattern. And so, for example, if you type tidy select colon colon, which is going to bring up all of the tidy select functions, and you type it into your console like this, so not the editor, but the console, and you kind of just hover and don't type anything, you'll see a bunch of functions pop up. And so it could be that it contains a letter, that it ends with a letter. Everything will select all of the columns. So you'll get a little description about what they are. So here are some common ones to use. So it's one of if it exists, basically. That one's a little more complicated, so don't worry too much about that one. Say you want the last column, you want the column to end with something. We had starts with, and contains is probably the most useful, I think, as well. So it's just, does it contain some pattern? Like, for example, we could do, does it contain a T? Then it would get these two. Okay, so in summary, the base-R way to pull the values from a column is to use this $sign. But the pull function is the tidyverse way. And to get sort of a Tibble version or a data frame version where you actually have a column, you're gonna want to use the select function. And the select function is super helpful because you can subset your data based on patterns within the column names. Okay, now on to lab part 2. I'm muted. Now we're going to talk about subsetting rows, which there were some questions about this, so we're going to cover that now. Oh, and yay, I'm glad to hear the labs are helpful. So the function to use to subset rows is called filter, and it's a super powerful, really great function from dplyr. And so just like before, we're going to have a similar structure where we first write the data that we want to work with, and then we're going to have some condition, and it's going to be based on the columns. So we want to subset rows where the MPG value is greater than 20. And so the output here, we're not assigning it to anything, we're just printing it to the screen. We see here that all of these values are greater than 20. And we don't need quotes here. There's some questions about that. You don't generally need quotes when it's a column name. If it's something that's new that hasn't been added yet, then you're going to need quotes. So there are lots of conditions that we can work with. If we want to say that it's exactly equal to something, then we'll use the double equal sign. The reason why we don't have the single equal is that's what's used for arguments and sometimes assignments. So since that's for assigning arguments, we're going to need the double equal. And you can think of this as exactly, I think of it as the first one being exactly equal to. And indeed, it's very specific. Like if you're using numeric values, it's not going to be like 11.1. That will not work. It has to be exactly 11, for example. Okay, so then we have our exclamation mark, which, like other languages, if you're familiar with other languages, often means negation or not. So this will be not equal to. And then we have greater than or less than, greater than or equal, less than or equal. And is an ampersand, and or is a bar. And sometimes it's hard to see on your keyboard where this key is. And so it's often under the delete key, but if you have trouble, let us know. Sometimes it has like a notch in the middle of it. Also, we have an error with filter. I can go back. So you might need to recreate data frame again. So you would do data frame and then the assignment arrow empty cars. And then you can try running this code. But again, don't worry about it if you're having trouble, because we'll go through these during the lab. Okay, but sometimes you have more than one thing that you want to check for. So, we have this exactly equal, you can only put one thing there. And so that's kind of annoying. And so sometimes you want to know multiple things. So in this case, we want to know, are there any cars in data frame where the miles per gallon variable has a value that's either 20, 21, or 22. And so we can combine these values together using our nifty combine function that we have already used before. And so it's just basically, are any of these values in this vector? And so in this case, we only happen to have values of 21. If we go back here, we have a 22.8, but we don't have exactly 22. So that's why it's not showing up here. And same for 23 or 20, whatever it was. So if we look at 20, we come back here, we don't see any values for 20. This is greater than 20, so we want to look at the original data, but you get my point. All right, and then we can combine these conditionals together using and, comma, or. So and comma is the same. I think it's better to use and because it's a little clearer to read. So here we're asking, in our data frame that we're working with, which rows have an MPG value of greater than 20 and also cylinder of 4, of exactly 4. So in this case, we have to meet both conditions. So if we had a value that was, say, 24 for MPG, but it was a 3-cylinder car, we're not gonna keep it. So like we go back here, there's a bunch of these that are over 20, but they have 6 cylinders, so they get dropped. And so we would get the same output if we used a comma, like I said, but I think it's best practice to stick with ands because they're a little easier to read. Okay, and then we have our or symbol here. And so an or statement is when we're asking the data to meet either condition. So it can be greater than 20, or it can be exactly equal to 4. So now we have basically similar data to when we just did greater than 40, because here we have cylinder values where we have a not equal to 4. And that's because it meets the requirement of being over 20 for MPG. We could have a value that's, for example, 19 and 4 cylinders. And that would also meet the requirement because it would meet the cylinder of 4 requirement. One way to check a package is to type in a function and then put a question mark in front of the function name and then leave the parentheses empty. And then it'll provide documentation about it. So I come back here and I say row names to column. So here it's coming up, and maybe I don't even remember the full name. Then I can just type in row and it'll come up. And you'll see here in my help pane. Did I share this correctly? Am I not sharing it?
Yeah, we can see it.
Okay, good. That now we have documentation.
Can we, just a quick note here, this works for functions that you have loaded. So if it's a function that maybe you don't have loaded, if you do 2 question marks, it will kind of search the whole of our packages. So that can be really handy if you're stuck.
I added a whole bunch of package troubleshooting issues to the R help channel on Slack. So if you run into troubles, give that a look.
Thank you
Awesome.
so much. There's also a which function, which you'll see more often. It's a base R function, and it's more for looking at where the values are. And so sometimes this can be helpful when we're doing a complicated filtering. And so I'm just demonstrating it in general in case you see it, and we might see it a little bit later in the class. But it's doing something similar to filter, except it's just showing us where the values are. And in this case, I have to just select, which variable I want to look at. So first I'm saying I'm looking at the data frame called df. I want to look at the carb variable, and then of the carb variable, which is exactly equal to 4, and which rows is that basically. And so it's saying that it's 1, 2, 7, etc. And so if I just select this out to test that and see where the conditions are for that, I'll see that indeed it's true for 1, 2, and 7. So just something to keep in mind. All right, so in summary, filter is what we use to subset rows based on logical conditions, which are based on our columns. The double equal sign is the same as exactly equivalent or exactly equal to, and means that 2 conditions must be met when we're using filter. The or symbol is that either condition can be met, and which shows you where those values are that need a condition. Okay. All right, so if you recall, I told you that you could combine filter and select, and to do that, you can nest them. So you could do something like this, where you're first filtering the data frame for MPG greater than 20 and cylinder exactly equal to 4, and you want to have the output result only show cylinder and maybe HP. MPG would probably make more sense, but say this is something you wanted, you could nest filter inside of select. And so basically it's getting the result from filter, but then only showing us the column cylinder and HP. Another way that we could do this is to assign a different object in between. So first we could filter our data and create a data object called data frame 2, and then we could select out the data that we want. That's another way that we could do it. Or we could use pipes. So the pipe notation looks like this. It's kind of an unusual looking notation. So it's a %, a greater sign, and a percent, kind of similar to the in, but in this case, it's an arrow. So this is trying to indicate an arrow for another step. And so we can kind of think of these as sentences. And if you're into shortcuts, you can use this shortcut. And so basically we can read this like a sentence as we're taking the data frame and then we're filtering it and then we're selecting these columns. All right, now we're going to talk about adding and removing columns. So the base R way is to use this, use our $sign, and we could make up a new variable name or a new column name. So we're going to call this new column. And then we could make it based on an existing column, which is weight, and we're going to divide it by 2.2. And so now we see that there's a new column when we use head on this new data on the data frame. The data frame is updated because we assigned it here, and we can see the new column here. But the tidyverse way is going to be a little bit confusing at first, probably. Just remember that tidyverse kind of works more in a sentence or speaking type of code. And so we're going to use a function called mutate, which is in dplyr. And so this is generally what it's going to look like. We're going to have some object that we're trying to update or create that we're assigning to our assignment, like typical. Here's mutate, and just like before, it's a function. So we have our parentheses, we have our data that we want to use, and we have a new variable name that we're creating, an equal sign, and the source of where that variable is coming from. And so here's an example that makes it a little more clear. We're mutating the data frame and we're reassigning it to have a column called new column, which is the weight variable divided by 2.2. If we wanted to get rid of a column, in base R, we would do something like this, where we assign it to null. In tidyverse, we can select it and use a minus sign in front of the column that we don't want. So now we're getting rid of that new column that we just made called new col, and it's no longer there. Otherwise, you can simply select the columns that you do want. So you could select MPG, etc. You could list them all out, or you could use a colon and then say carb, and it will select everything in between. Remove is going to remove the entire, like you can use it to remove an entire object. You know, it's a little easier with these functions to keep with the sort of thing that we're doing here. If you wanted to remove multiple columns, you could use the combine function again, and this is just the same notation of using the minus sign. And now we're going to talk about ordering columns. If we want to order columns in a different way, we can use the select function and just write the columns in a different order. But there's also a function called relocate. If you have a specific thing that you want to do, and you say you have like 31 columns and you're not going to want to write them all out, then you can say, for example, we want to have weight, which is right here in the middle, and we want to move it to be the first column here. We can use the relocate function to take the data frame that we're working with, reassign it to this new data frame called data frame carb, and we're taking the weight variable and we're moving it to before the MPG variable. So there's this argument that looks a little funny. It has a period in front of it. There's either a dot before or a dot after. And so that can help you to specify where exactly you want your column. So you could put it anywhere you want, but typically I use this function if I want to move something to the front to be the first column. Okay, ordering rows. There's a function called arrange that helps us arrange rows, and it automatically does it in ascending order. So if we're using our data frame here and we want to arrange it by MPG, it's going to sort all of our car values. Now you can see that it's starting with the Cadillac Fleetwood, and previously it was the Mazda RX-4. So it's changed the order of the rows. And we can see that MPG is increasing as we go down the tibble. If we want to change that to decreasing order or descending order, we can use the descending, which is DESC, short for descending function. And we just put that in front of MPG that we want it in descending order of MPG. And so now Toyota Corolla has the highest MPG value. And so that's our first car. And you can see that it decreases over time, or over the length of the tibble. Yes, this can get really complicated if you'd like it to. So say we want to arrange our data frame by MPG first, and then secondarily by the descending of HP, we can do that. So first it will sort by MPG. And so we see that this is relatively similar to what we saw before. But then it's instead of having the Cadillac Fleetwood first, we have the Lincoln Continental because the HP value is higher for the Lincoln Continental compared to the Cadillac. So in summary, select and filter can be combined together. You can do sequential steps in a variety of ways. One is nesting them inside of each other. I don't recommend doing too much of that because eventually it gets kind of confusing. You can create objects or reassign your objects in between steps, or you can use pipes and think about it as like a sentence where everywhere you have a pipe, it's sort of like and then, etc. Arrange is what you use to reorder rows, whereas select can be used to reorder columns. And if you have a specific relocation of a column, you can use the relocate function. And to remove rows, we use filter. To remove columns, we can use select with a negative sign, or just select the columns that we want. We can assign the column to null. And that's about it. And finally, a very important function, a function to remember that we're going to be using more, is this mutate function, which helps us to create new variables or modify existing ones. And so this could be, say we just wanted to change weight and we wanted to divide it by 2.2, then we would just put weight here and weight would be changed in our data frame. Okay. So if there aren't any questions, we'll move on to the lab.